Thank you. I'm Rajiv Dholakia. I'm with a company called Knock Knock Labs. We're a relatively small company based in Palo Alto, California. We work on authentication infrastructure, software, and standards. We're probably best known for being one of the founders of the Phyto Alliance, which if you heard the keynote this morning, you may have heard a little bit about. We put together some of the core protocols and are co-authors on some of those standards, and we supply software to people that like Entity Docomo, PayPal, Alipay, et cetera, that uses that software. I'm going to talk a little bit about the advent of biometrics in general and some of its intersections that are happening in the IoT space. So, I'm a chemical engineer by training. I wandered around in the AI space in the 80s and worked with operating systems, and I've been working in security for about 20 years. And I like this gentleman, Henry Petroski, who's a civil engineer by training and someone who spends a lot of time understanding how designs fail. We've all heard the enthusiastic projections about how many devices we're going to have and how IoT is going to transform our world. And IoT is a big space, but perhaps to simplify it, particularly in the context of consumers, we can start to talk about things like a connected car, connected home, connected health, connected cities. So how are we doing? Well, here's the preview. A relatively trivial attack not too long ago took down large swaths of the internet by virtue of the ability to hijack some IP cameras that had embedded passwords in them. Okay, so that's not good news. If HP did a survey a while ago to look at some of the existing IoT devices and found them sorely lacking in terms of the ability to do any kind of advanced authentication, and if you look at OWASP, that characterizes some of the vulnerabilities that are present in this space. Number two is this idea of insufficient authentication and authorization. So where is this all leading? Maybe we're going to see Alexa wake up overnight and get annoyed with us and start to destroy something in our living environments. And I think if I trace back and look at what the root causes of many of these kinds of issues have been, it seems to be the case that we've forgotten that there's actually a you in IoT. And what do I mean by that? Which is almost any instance that you look at, there's some class of user that's involved in the IoT infrastructure. It could be an admin that sets up the devices. It could be an admin that administers those devices over a cloud. Or it might be an end user that interacts directly with those devices. And unfortunately, they're rarely factored in. And so we keep talking about IoT as if there's no user present. And unfortunately, there's a law of unintended consequences when you frame things the wrong way from a design perspective. So let's segue then and talk a little bit about user interaction and IoT. And I like to say there's a simple way to figure out where things are going, and the answer is watch where the money is flowing. So back I think in 2012, 2013, Apple put a big bet down in this space by buying a company called Authentic. They made fingerprint sensors. And you've sort of seen the tip of the iceberg in terms of the use cases that they had envisioned rolling out. So you've seen Touch ID, you've seen it used for opening the device, you've seen it now in the context of the App Store in terms of Touch ID and payments. If you're thinking now about things like HomeKit and some of the IoT work that Apple's doing, if you start to think forward, you'll see very clearly that there's a very deliberate set of thinking that's been applied to how user interaction, at least for the Apple ecosystem, is going to evolve, and biometrics are going to be a big part of it. Very recently, just to fast forward, I think maybe about 2 weeks ago, 3 weeks ago, Synaptics acquired some assets in this area for voice and video, making the assertion that human interface is essential for consumer IoT. So with that in mind, let's talk a little bit about what I call primary interaction devices. So if you've established the case that there are users that are involved with IoT in some capacity, either as admins or as end users, then how do these users interact with these IoT systems? Well, typically there's some kind of a primary interaction device. And these primary interaction devices today have a certain shape and form associated with them. Typically it looks like your phone, but there's a lot of other classes of devices, and I think more people are these days familiar with things like Alexa and some of these Google Home type devices that are popping up. What you probably haven't seen is some of the prototype devices that are floating around the industry right now that have a lot of this stuff embedded in a far more invisible way. And what's interesting and important is that these devices are starting to embed some native biometrics into those interaction devices, similar to what the phone did. And you can verify the user through that user interface. You can connect to another device or to a cloud service. And the biometrics involved can be active or passive, meaning that the user may need to actually gesture or swipe a finger or something like that, or it might be that it's just assessing you in a passive way. Many of these devices, and Rob, I think, may have covered this in some of the earlier discussions, now have foundational elements that are built in that allow you to attempt very good security for some of that biometrics. And what I'd like to say is that you ain't seen nothing yet, right? Because maybe about 10, 15 years ago, folks at MIT were walking around with wearable computing. So the whole modality of how you interact with devices and how they interact with you will change, and the ability to incorporate various kinds of sensors, biometric and otherwise, yield some very interesting possibilities in terms of how you construct these kinds of environments. Okay, so again, Petroski says, in design, for every advantage that you introduce through redesigning these systems, there's some accompanying disadvantage. So what might be some of the perils associated with putting biometrics into the IoT space? Well, obviously one of the first ones is this idea of security, which is if I have biometric templates that are floating around in these devices, sometimes that's not such a great idea because that's leakage of personally identifiable information of some kind. If you're aggregating these templates in some place, that becomes a point of attack. The ability for someone to mount an automated attack on these kinds of things so that they can create unauthorized access to those devices becomes a problem. And then, of course, you have to think about the problem of lifecycle management, disposal, repair. The illustration here is a special device which, if you're an Apple fanboy, you probably would recognize. Because if you've ever cracked or dropped your iPhone, the repair conditions associated with replacing parts is a little bit complicated because of that thing called Touch ID. So it's not any mere mortal that gets to go mess around with these devices. There's actually these very, very specialized machines that come and do it. So biometrics could pose some interesting challenges, but it also poses some interesting promise in terms of being able to secure these interactions. So let's talk about the positives for a second. So I'm a security guy. I like to think in terms of threat models because that's a very clean way of making sure that you don't run around with your hair on fire every time there's some vulnerability announced. So threat modeling, if you haven't heard about it, go look it up. Adam Shostak wrote a nice book on it. And it's something that even as an identity professional, you must know and read about. So what are some issues with respect to threat models? Well, obviously, in IoT devices, you can go after the firmware or exploit some operating system or app vulnerabilities. And there are some remediations that are present now in the mass market at very affordable scale for making sure that you can harden yourself to these kinds of attacks. And obviously, you can try and enter at the front door by either impersonating the device, create a virtual machine of some kind, and then go in and push fake data into your IoT network or create interactions that are meant to poison the integrity of that network. Or you can impersonate the user that's associated or affiliated with that IoT device. So really what we are looking for and what the focus of the remainder of this talk is to talk about this idea of can we do strong authentication to protect ourselves against these kinds of attacks. So a quick primer on securing devices in general, securing IoT devices in particular, which is the first thing you got to do is to go harden the foundation to make sure when you boot that device, you can verify the integrity of that device, and this is all about hardening at the CPU and chipset and board level. And there are a good set of folks at ARM and Trustonic and other places that are off doing that. You need to isolate how those applications get onboarded, who controls how they're onboarded. There are things like trusted service manager concepts associated with these hardened devices to allow you to do that. You can filter the applications that you bring, and then you need to use some kind of strong authentication, which is essentially after having made sure you have a good foundation and a strong roof and bars on your windows, make sure that you lock the front door, right? So we're going to talk about locking that front door. And the problem today is that we are designing many of these IoT systems in what I'd call silos. So Apple has its own set of mechanisms and Google has its own set of mechanisms. It's very early in the marketplace. There isn't a clean set of standards. And so it's a little bit like the Wild West. However, if you look underneath all of these connected user, connected device across all of these different manufacturers, you come up with essentially four patterns or four use cases. There is this problem where users are authenticating into clouds, typically to instruct a single device or a cluster of devices. There are users that are authenticating directly to devices. There are devices that are authenticating directly to devices. And there are devices that are authenticating to clouds. And so how do we propose to solve this? Because if we do what we've done with IP cameras so far in terms of embedding passwords and use bearer tokens that can be trivially replicated somewhere for access, we are toast, right? Because that's going to set us up for some bad pandemics. As an FBI agent said to me the other day, that things like the DIN attack, they're just probes. That's just people sort of feeling around the edge of the system and seeing what kind of disruption they're really capable of doing. They're going to go exploit it for economic purposes down the road. So there are some opportunities to prevent these kinds of problems. And there's some promise in some of the standards that have been dealing with biometrics that can be brought into the IoT space. So Knock Knock Labs, among 4 other people, PayPal, Infineon, and a few other companies formed this thing called the Phyto Alliance with the mission long-term of trying to eliminate the use of passwords and symmetric shared secrets. And it turns out that many of the things that we set out to solve are patterns that are being repeated in the IoT security space. So for example, symmetric shared secrets lend themselves to scalable attacks. We want to eliminate symmetric shared secrets. You have this problem when you're talking to a device on the other side of the network of trying to distinguish whether it's a virtual machine or it's some kind of a real device. And Fido has attempted to try and bring forward some abstractions and solutions to this particular problem. So I'm not going to give you a big tutorial on Fido, but essentially the way that Fido's been set up to work is there is this abstraction called an authenticator. What the authenticator is it's not a single thing like a fingerprint sensor. It's an abstraction that includes some kind of a gesture and some kind of a cryptographic process. The way it works is the user may be using a device where they authenticate to the device and then the device authenticates into the network. So there's two abstraction layers. One abstraction layer allows you to plug in different methods of authentication. The other one makes sure that there is a tight cryptographic coupling between the device, native cryptography, and the server that's calling in to request authentication. That prevents things like man-in-the-middle phishing and other kinds of problems. So essentially, what we had to do was, in order to make sure that we had a good user-to-cloud authentication capability, we had to make sure that we had a good solution for users authenticating to devices, and then for the device to authenticate to the cloud, which, if you think about it, really is the device talking to another device, which is a server in that particular case. In the IoT situation, that server in the cloud isn't really a big honking server. It might be a microserver that's sitting in a car of some kind. But it's essentially trying to answer some simple questions. Am I dealing with a real device? Am I dealing with the right user? Am I dealing with a right specific device? Remember, a real device doesn't really tell you that it is Rajiv's device. That's a different problem, right? I'm just looking for the fact that this is something more than a VM. It's a real device. It's of a certain class. So right device, right user, and is this an acceptable method of authentication, which is the way that this device or this user is verifying itself? Can I understand the security envelope around it? So this is not theory. Fido's been deployed out from a capability perspective to a very, very large population through some very big brand names. And in the case of IoT, we've done some work. There's a company called Gallagher on the floor in the Fido Pavilion. If you haven't talked to them, they're a partner of ours. They're the second largest manufacturer of physical door locks in the world and access control systems. And they had this interesting problem, which is the control systems that control their doors are embedded systems and not capable of hosting, big servers. And so there were some interesting adaptations of the Fido protocol that have been deployed out, so that for them, what IoT translates into today is, if you're outside the secure perimeter of a building, you're required as a user to swipe your finger and tap the phone to walk into the building. Once you're inside the secure perimeter, you simply need to tap the device and go. So you're saying, okay, well, that doesn't sound so much like the IoT things that I'm thinking about. Well, it turns out that the design pattern's actually quite similar. So here are two use cases that are perhaps more identifiable for you. One is renting a car, and in doing so, you might go rent a car through a cloud rental service of some kind. And then you are granted access to the car, and you have to walk up to that car in the depths of an airport garage that has no connectivity and prove who you are to that particular device. At some point, the interactions within the car may allow you to unlock Sirius XM radio or tolls or other kinds of interactions. And then the device itself, the car, may have to reconcile usage at some point with the cloud. There are similar use cases with things like storage lockers, and it turns out all of the things that we've talked about from an authentication perspective come into play. So just tying this all together, biometrics in the IoT and consumer space is sort of inevitable. It is happening. Done badly, it'll really subtract privacy and security. And we have an opportunity today to try and secure some of the consumer IoT stuff that we are rolling out, so that we don't set ourselves up for the kind of pandemics that you saw with the IP cameras and the DIN attacks. And because authentication is some of the first experience that users have in setting up the devices or administering changes to those devices over a period of time, I call it the gateway to user experience. If you get that right and you make it seamless, pleasurable, and still secure, your users will appreciate it. So we can do better than usernames and passwords. There is this concept in Fido that may, while you think about Fido and the Fido standards as being related to end users, 5 years ago when we were setting out on this journey, we felt strongly that there were use cases where you would care to authenticate the device but not necessarily care about who the user was attached to it. Think point-of-sale terminals or ATMs or things like that. So it turns out that the design pattern that we incorporated into the protocol applies very nicely into IoT authentication across the 4 kinds of use cases that I mentioned. And then in particular, when you're thinking about things like offline authentication, where you're walking into that airport garage and tapping a phone to open a car, you may end up doing that through roots of trust, but hopefully you'll avoid the bearer token problem and use something like a proof of possession. And Fido, because there's a private key involved, that private key is typically protected in a strong way in a trusted execution environment or a secure element, lends itself very nicely to this idea of a proof of possession key. So that is the sum of my presentation. I hope that was useful to give you a quick orientation into this space, and I'll be happy to take questions.
So any questions?
Can you give us a use case? How do we make a user to be authenticated by the device? So device itself doesn't have user information, right? So how make a user can be available to be authenticated by the device itself?
So I think it, if I'm understanding your question correctly, you're asking how do you set up devices to recognize users? Is that the basic idea? So I think that there is a spectrum associated with what you can do that ranges from recognition to authentication. And to make the distinction between the two, I might care that I'm dealing with a certain class of individual, a grown person, a male, a female, a child, etc. And so today, from a sensing perspective, you have systems that are good enough to recognize cats on the internet. You're not very far away from being able to distinguish between classes of individuals. Authentication is a little bit more complicated because that's typically associated with an identity of some kind, and there's some pairing process involved in provisioning an identity and an authentication credential. In this particular case, in the case of biometrics, the user themselves may be presenting themselves as the credential by presenting a face, by presenting a voice, by presenting a swipe of their finger, and you know you see that provisioning process today when you set up devices like this, Samsung, Apple, etc. With IoT devices, we are still in the early phases of figuring out what the setup for these devices will be. There are clumsy mechanisms like QR codes and such today paired with phones. And so you authenticate, for example, with Touch ID on this device, and then you might authenticate over Bluetooth or Wi-Fi into a door lock. So the door lock itself may not have a fingerprint sensor. Your device today does. There are people, by the way, who are out integrating all sorts of interesting biometric capabilities into those edge devices themselves, which I think is maybe a questionable proposition. You don't want these kinds of things from a privacy perspective necessarily, and a security perspective. You don't want to have to go register for every door lock in your home. That sort of doesn't make sense. So still early days, but yes, there are patterns that range from recognition all the way to authentication, and they can be managed very nicely. Up here.
Thank you. You just exposed a scenario which I call the paradigm of identity propagation through IoTs. And my example is like me to my watch, to my car, to my physical GPS, to my cartography software, to my favorite of restaurant. So how does Fido fits into these? The authenticators that you are talking about can help to handle such scenarios, and what are your recommendations based on those scenarios?
So again, if I understand your question correctly, the idea of users authenticating to devices is a pattern that you see every day. You're trying to prove who you are to your watch, your phone, or something else. So in fact, the fundamental foundation of Fido was that we had this trouble with passwords, which was something that you know, and it wasn't particularly natural for users, and they were cognitively overloaded with things like complex passwords. What was more natural to users are things like gestures or tokens that they carry around with them. Someday you might implant something in your body and carry it around with you. There are all kinds of possibilities. So the question is, how do you incorporate all of these different mechanisms that authenticate people or devices, and how do you manage them without having different silos of how you do it? And then the analogy that I often take to help people understand what Fido is think about the electrical system in your house. Somebody figured out how to take electricity from the pole, put it into a panel, subdivide the circuits, put standard cabling through your house with Romex cable, and give you standard interconnects so that you can buy a blue toaster or a green toaster or a combined toaster and microwave, right? The infrastructure is agnostic to the specific method of authentication. So what Fido's done is basically try to standardize the electrical system in your house so that you can pick the method of authentication that is most appropriate to you. I say the right method of authentication for any particular use case is a combination of three things, which is what usability do you want? What level of security does your use case require? How much risk are you willing to take? And then what are the economics that you're willing to bear to solve that particular problem, right? Because in abstract, it's very hard to say this is the perfect method. It's really the combination of those three. And the purpose of Fido is to allow you very flexible choice in picking the right one without having to change your developer API, without having to change your backend, and without having to have your developer trying to understand and navigate the nuances of specific methods of authentication in this kind of biometric versus that kind of biometric, or this kind of security mechanism, secure element versus TEE. The developer abstraction becomes very simple. Authenticate the user using the policy that I got from the server, or device authenticate yourself in response to this challenge.
I have one last question. When do you think we'll see smart speakers with Fido capability to stop the problem of dolls' houses being ordered?
Say that one more time?
Yeah, smart speakers with Fido capability to do user recognition and to stop dolls' houses being ordered by children.
I have to say I've seen prototypes, right? I think the question is modeling use cases and mass market scenarios is an interesting thing. What I'll point out is that sometimes this kind of evolution happens in fits and starts. If those of you follow this kind of stuff, Apple got sued at some point for the fact that children were racking up heavy charges on the App Store because of unauthorized purchases through apps, and there was eventually a settlement associated with that, and mechanisms that were put into how the App Store works, and delegated buying happens through apps to prevent that. So I think it would be a good problem to solve. The question is whether it's a important problem to solve for some of those manufacturers today.
Okay, we're out of time, and thank you, Rajiv. Excellent presentation.
Thank you.
5 minutes until we'll hear from Mans Harman on blockchain and IoT.